So this video is kind of a closing video for the element14 2021 Design for a Cause challenge. I'm going to go over my Arduino code and kind of explain everything I did and where I'm at. So the first thing is, if you happen to notice and you're familiar with this type of naming, this is my third version of the controller. Each time I made a notable change, I just saved it as a new document. The main reason being is I have something to fall back on. If I screw something up and I don't know what I did, I can always just ditch what I've done and go back to something I know that worked at a stable point. And I highly recommend getting in a habit like that. It's a hard habit to get into, but it can really save your hide, if you royally screw something up. So aside from that, getting into the code, I had to do a couple includes, math, because I'm doing some conversion of numbers. I had to include the Arduino Bluetooth Lite libraries, and so the BLE, if you noticed in one of the other videos, I was referencing on when I was building the app, I was using just regular Bluetooth, and the Arduino Nano 33 IoT, it uses Bluetooth low energy, so the light version, and the regular Bluetooth doesn't work for that. And then when I originally started this project, I just tried to use some old code that I had which used Bluetooth, and it didn't work at all, and so I had to scrap all that and figure out why I was screwing up. So I declared some pins that I was using, and I did this just so when you get down later in the code, you know why we're doing that analog read a little bit easier. It just doesn't say A0. We know that we're doing a read of our soil moisture sensor type thing. And I also had to create some variables for various things, and I had to flip-flop around as to what type of variable I used to get the result that I wanted. A lot of it was trial and error. Sometimes you just start out with an integer and you have to move through different ones. Like on my temperature sensor, temp variable, I had to use a float, and that's because I'm dealing with decimals and potential negative numbers. So I needed something that could handle a wide variety of stuff, which made it a little bit more difficult, especially when I started messing with the Bluetooth. And honestly, some of the stuff in here is stuff I haven't gone through and cleared out. It was there through experimentation. So then I get down into this. This is the Bluetooth side of thing, and the Bluetooth video explains this in a little more depth, but these are just the variables for Bluetooth, basically. And so you have to have a service, and then you have to have characteristics within that service, and these are basically the variables. So I store my soil value, basically if it's moist, the soil's moist or not. My temperature, this is the temp setting degree. Do I want it in Celsius or Fahrenheit? It's just a variable to store that. H2O value, my water level sensor, and then pump state is my pump on or off. And I have to do this just for passing information back and forth between the Arduino and my phone that's running the app. Then in my setup, you don't always have to do this. Sometimes I do it just for clarity, but declaring a pin mode, input output, most of the time Arduino works just fine without declaring it. I was having an issue earlier on, and so I tried declaring it to make it work better, and I ended up doing it for all of them after that. I'm using the serial print for debugging, so I have to declare that, and during my development, I realized that the way, starting here right after I do an initial print showing that it booted up successfully, that I'm having an issue because I jump into this if statement first thing. And so I'm going to have to go back and revise this code even further because by default I can't read anything. Even though it's running, it's just not printing anything out because I'm connected to Bluetooth. So I'm going to have to go back and find a better way to revisit that. But this if statement, the first thing it does is it checks to see if Bluetooth connected. If it didn't, it says initialization or connection failed, basically. But if Bluetooth is connected, I start doing stuff. I set some variable stuff mainly, and then I print saying that we connected, and then I do some more declaration stuff. And actually, you know what? This hasn't done once, so I don't think this code is actually doing anything. And I've never seen it, so I'm beginning to think that these 2 bits of code right here are worthless. I can probably weed them out. Here I'm adding the characteristics that I declared up there into this service, and then this right here is a very important declaration. This tells the Arduino to broadcast that it is a Bluetooth device and it can be connected to. So very important. And honestly, this right here is something I picked up from someone else's project. I can't remember who it was. I wouldn't have used it if I hadn't seen someone else doing it, because honestly I'm not that well versed in the Bluetooth yet. But it's an event handler for connecting and disconnecting. And if I scroll down to the bottom here, we can see what it does. So on connection, all it does is serial print, connected event, and it prints the MAC address of who connected to it. And then if you disconnect, it says disconnected, and it prints the MAC address of what disconnected from it. This is a great little debugging tool. So you can monitor the serial print and you can tell when stuff connects and when it disconnects. So I highly recommend that little bit of code. It's not necessary to make it function, but it's great for debugging. Then in my loop, like I said, I was trying to learn the Bluetooth and I saw this used in some examples, so I put it in there. Honestly, I don't even know what it's doing. So I'll do some more learning and research and experimentation to see what it does and see if I even need it. But then I start a while statement. While Bluetooth is connected. And this goes back to what I was saying earlier. This stuff only happens while it's connected. I'm not seeing any of the pertinent information what the Arduino is doing unless a Bluetooth device is connected, which means every time I wanted to debug, I had to waste time by actually connecting to it and on my phone before I would ever get it to print anything. So I need to go back and make some changes to this. But you can see the first thing I do is once I have a connection, I do a soil read. I basically read my analog pins is all I do. Then after that, once I've got these values saved, I start to do some processing. So if the soil, and actually what I have up here isn't the most recent. The most recent code is on my laptop and I'm on my desktop right now. So, but I've updated this value here. If you saw in one of or in a coming up video, you'll see that where I talked about doing that. So if the soil, basically if it's reading moisture, then the first thing it does is it turns off the pump. So the pin that I have the MOSFET connected to, the gate of the MOSFET, it turns it to low, or it turns it high, which stops the current flow. That's all I'm doing here. Or actually, well, I said that wrong. It creates a high which turns off the transistor that controls the gate. Because if you remember from that other video, the Arduino Nano 33 IoT operates on 3.3 volts, but my pump is 5 volts. So I had to use the transistor to create a 5-volt switch, and it got really complicated. I finally figured it out after about a day fooling around with it. But then, whenever I make a change to something, I have to update my Bluetooth variable, as well as my intermediate variable that I use for monitoring within the Arduino. But if the soil is dry, i.e. not high, then I check some other stuff because we may have to pump. So if the soil's dry, first thing I do is check to see if my water level is up. So if I have a water level, have water in the reservoir, I turn the pump on, and I do that by switching this low. So then I write my variables to for Bluetooth and for referencing in here. Else, if my water level is low, turn the pump off and set values to as needed. After that, I do a check to see if I'm going to be doing Fahrenheit or Celsius. And so it checks to see if the app has sent a value first. It gets that value, and then it sets my temp degree to whatever that value is. Now, this isn't perfect, but it functions. I don't have any default variables set up at this point, which I need to, I set it up to actually 0 is default if we remember back up here at the top. So Celsius is default. 1 is Fahrenheit. Then I need to do, I need to take my temp value, my analog read, and I need to get an actual temperature out of that. But the way that I do that is I created a function, and this is my first time working with functions, I believe, or successfully working with functions. So I created a function called tempcal, and this function passes 2 variables. So if I scroll down here, we can look at it. And I have another video that goes over this in much more detail, explaining what it does, but it brings back the actual value that is degrees Celsius or degrees Fahrenheit. And then from there, I check to see if, and this is going to be for future stuff, I never got this to work the way I wanted it to. So I have to go back and check it. Or, well, I never finished it is what it was. But it checks to see if the app turns the pump on. This way you could remotely turn the pump on for whatever reason. It's just an option. And so did the Bluetooth value that holds the pump state get written? If the value is this, what it's going to do is actually turn the pump on. Else, if not, turn the pump off. And what will happen is the pump will run for 1 second as this loop works, because this loop only runs once a second. After that, it's just some debugging stuff here. I print out all my values, and then actually there's some redundancy here, or well, this is checkup, because my pump status is a Boolean value, true or false. So I have to read that state before I know what the value is, and then I print out what it is based on that. And then here's that 1 second delay that I said. And that's mainly just to make the serial monitor easier to read. In the future, it's actually going to be longer, because remember, this is going to be a remote location type thing, low power, so it's probably only going to read like maybe once every 10 seconds or maybe once a minute, or maybe even longer than, once every hour. There's a lot of options with this as the way we do it. I may end up having to go in and add an interrupt button on it, to where if someone wants to connect via Bluetooth, they go hit the button and then they can connect via Bluetooth and then control it, and it changes everything. But that's the more advanced version. This is just to get me running. This is the code that's currently running, and at this point I'm a week in and my plant's alive. It's that's nothing great, but within 3 days of no watering, a plant can die very easily. So the 3 herbs I've got going in this pot are doing fantastic, and it's this code that's keeping them alive. Like I said, there were some updates to it. It was mainly just changing this value to a higher number, because my testing said one thing and then the real world did another thing, so I've had to adjust that. But that's it. That's where we're at. I hope this helps someone, and I'll keep revising this and making updates.